Hello dear students. Today we'll be talking about equality of two algebraic fractions. Let's start by simplifying the algebraic fraction. To put the algebraic fraction in the simplest form, you need to follow the following steps to simplify this algebraic fraction. The first step, you need to factorize both the denominator and the numerator perfectly. The second step, you need to identify the domain of the algebraic fraction before removing the common factors in the numerator and the denominator. Remember very well, you need to find the domain of this algebraic fraction before you cross out the common factors in the numerator and the denominator. The third step, let's now go and remove the common factor in both the numerator and the denominator to get this fraction in the simplest form. Let's go and see an example to understand it more. Example number 1. If n of x is x power 3 plus x squared minus 6x over x power 4 minus 13x squared plus 36, then we need to reduce or to simplify function n of x and make it in the simplest form, showing the domain of n. Let's go and see the steps. First, as we said, we need to factorize perfectly the numerator and the denominator. As you can see, the denominator will be x squared minus 4 multiplied by x squared minus 9, where the numerator will be x open bracket x squared plus x minus 6. Can it be factorized more? Yes, for sure it can be factorized more. How to factorize it more? X in the numerator, x open bracket x plus 3 times x minus 2 all over x plus 2 times x minus 2 x plus 3 times x minus 3. From where did we get all of this? If you check the denominator in the first step, you will see that it's two brackets multiplied together, and each bracket can be factored by the difference of two squares. So x squared minus 4 will be factored as x plus 2 and x minus 2. And x squared minus 9 will be factored as x plus 3 and x minus 3. And the numerator part, the x squared plus x minus 6, can be factored as x plus 3 and x minus 2. Second step, don't cross out. Remember that you need to find the domain of both the numerator and the denominator first before you cross out. So the domain is all real numbers except, because we get the domain from where? We get the domain from the denominator, the values of x that make the denominator equal 0. So the domain is all real numbers except the negative 3, the negative 2, the 2, and the 3. So let's now go and cross out. The x plus 3 up will be crossed out with x plus 3 down. The x minus 2 in the numerator will be crossed out with the x minus 2 in the denominator. So the simplified function is x over x plus 2 times x minus 3. Let's move to another point, which is the equality of two algebraic fractions. Two algebraic fractions, n1 of x and n2 of x, are said to be equal if the following two conditions exist. Take care, the two conditions need to exist together. The first one, the domain of n1 of x must be equal to the domain of n2 of x. The second one, n1 of x and n2 of x must be simplified to the same form. Let's see an example to understand it more. The question says here, find n1 of x and n2 of x in the simplest form, showing the domain of the following. Now, let's go to n1 of x and find its domain. If you check it here, the denominator can be simplified more, can be factorized. So in n1 of x, it will be x plus 3 over x plus 3 times x minus 3. Get the domain first. So it's all real numbers except what values of x in the denominator? The negative 3 and the positive 3. So the domain is all real numbers except negative 3 and positive 3. And now we can go and cross out. So if you cross out x plus 3 up with x plus 3 down, it will be 1 over x minus 3. Let's go and simplify more the n2 of x. We're going now to factorize n2 of x. So you will see that the denominator of n2 of x is 2x minus 6. How to factorize it? We take 2 outside the bracket and then x minus 3. Before you cross out the 2 up with the 2 down, you need to find the domain. The domain will be all real numbers except positive 3. So now here, and then you can cross out the 2 up with the 2 down, and the simplest form will be 1 over x minus 3. Now we need to go and check for the conditions. Are the two functions simplified to be the same? Is the simplest form of the two functions the same? Yes, 1 over x minus 3 and 1 over x minus 3. Shall I go now and say that they're equal? No, I cannot do this because I need to go for the check for the second condition, which is the domain. Are the two domains the same? Definitely the two domains are not the same. So in this case, n1 and n2 are reduced to the same fraction, but the domains are not the same. So conclusion that n1 of x is not equal to n2 of x. Let's move now to example 3. Find n1 of x and n2 of x in the simplest form, showing the domain of the following. How to simplify again? We need to factorize the numerator and the denominator if we can factorize them. If we go and check for the first function, the denominator can be factored as 2 open bracket x plus 2. And before we cross it out, we need to find its domain. So the domain is all real numbers except negative 2. And now we can go and cross out the 2 from the numerator and the 2 from the denominator. Then the simplest form of this function is x over x plus 2. We need to do the same thing for the second function, the n2 of x function. We need to simplify the numerator and the denominator. For the numerator, we'll take x as a common factor. So it will be x open bracket x plus 2. And for the denominator, it will be 2 brackets x plus 2 times x plus 2. Or x plus 2 all squared. Now, before you go and cross out the common factors from the numerator and the denominator, you need to find the domain. The domain is all real numbers except negative 2. Now let's cross out x plus 2 from up and x plus 2 from down. What will be left for you is x over x plus 2. Now, you need to go and check the two conditions that we have. The first one, are the two functions simplified to the same simplest form? In this condition, yes. X over x plus 2 up and x over x plus 2 for the second function. Are the domains of the two functions the same? Yes, they are identically the same. The domain of the first function is all real numbers except negative 2, and the domain of the second one is all real numbers except negative 2. So in this case, can we say that n1 is equal to n2? Definitely yes. n1 is equal to n2, and the two conditions exist. Let's move on to another example. In this example, n1 of x equals x squared over x power 3 minus x squared, but n2 of x equals x power 3 plus x squared plus x over x power 4 minus x. The question is asking you to prove that n1 is equal to n2. You guys now know when are they equal. They're equal if the two conditions are there. The first one, that the domains are the same, identically the same, and the second one, that the two functions, when simplified to the simplest form, they must have the same simplest form. Let's go now and check the domain and the simplest form for each function. The first one, if you simplify it, the denominator, you take x squared as a common factor. So it's x squared over x squared times x minus 1. Before you cross out, you go and find the domain. And the domain is all real numbers except 0 and 1. And when you simplify it, you cross out x squared up with x squared down. So what's left up is 1, and what's left down is x minus 1. And this is the simplifying in the domain of the first function. Let's do the same thing for the second function. Numerator of the second function, you're going to take x as a common factor. You'll get a quadratic equation that you need to factorize. Here you go. The first one, we take x as a common factor. We will have x squared plus x plus 1. It cannot be factored, so it remains as it is. And for the denominator, we're going to take x as a common factor. It will be x over x power 3 minus 1. If you can factorize this cubic function or cubic binomial, you will see that we have an x outside as it is, and then x minus 1 times x squared plus x plus 1. Before you simplify, you need to find the domain, and then cross out the common factors up and down. What will be crossed out up and down? The x will be crossed out up and down, and the quadratic trinomial will be crossed out up and down. So, yes, what will be left up is 1 over x minus 1. And how about the domain? Is all real numbers except 0 and 1. In this case, from 1 and 2, you will see that they have the same simplest form, and also they have the same domain. Accordingly, n1 and n2 are equal. Let's go and see another example. If n1 of x equals x squared minus 4 over x squared plus x minus 6, where n2 of x equals x cubed minus x squared minus 6x over x cubed minus 9x. Prove that n1 of x and n2 of x are equal to each other for all values of x that belong to the common domain, and find the domain. Let's start by the first function, the n1 of x. Let's simplify up x plus 2 times x minus 2, difference of 2 squares, and factorize down as x plus 3, x minus 2. We're going to cross out the x minus 2 up with x minus 2 down, and don't forget to find the domain before crossing out. So the domain is all real numbers except negative 3 and positive 2. We always get the domain before crossing out. The second function, if you simplify it, the numerator, it's a cubic trinomial, so we'll take x as a common factor, and then we'll get x squared minus x minus 6, factorize it as x minus 3 times x plus 2. And for the denominator, we're going to take x as a common factor, so what will be left for us is x squared minus 9, difference of 2 squares, so it will be x plus 3, x minus 3. Yes, we're going to cross out the common factors up and down, but we need not to forget that we need to find the domain first. The domain down is R, all real numbers except 0, negative 3, and positive 3. And then we can simplify the numerator with the denominator by x plus 2 over x plus 3. So from the two domains that we have, you will see that the common domain is what that we covered before. Yes, excellent. From 1 and 2, you will see that they are, yes, simplified to the same simplest form, but the two domains are not equal. And the question is asking me to find the common domain. So the common domain is all real numbers except, yes, the negative 3, the 0, the 2, and the 3. They are not equal, but we can get the common domain. By this, we came to the end of our session. Hopefully you enjoyed it, and take care. As more you practice, as more confident you're going to be.